Look up on a clear day and the sky is blue. Look again at sunset, and suddenly it turns fiery red and orange. The sun hasn't changed, but the journey its light takes has. So why does the sky change color at all? Let's find out in this video. Sunlight may look white, but it's actually a mixture of all colors: violet, blue, green, yellow, orange, and red, each with a different wavelength. When sunlight enters Earth's atmosphere, it collides with tiny molecules of nitrogen and oxygen. These molecules are much smaller than the wavelength of visible light, and that's where Rayleigh scattering comes in. Rayleigh scattering is the scattering of light by particles, like air molecules, that are much smaller than the light's wavelength. Rayleigh scattering affects shorter wavelengths much more strongly than longer ones, and the shortest wavelengths in visible light are violet and blue. So as sunlight passes through the atmosphere, blue and violet light get scattered in all directions, while reds and oranges mostly continue straight. That scattered blue light is what reaches our eyes from every part of the sky, making the sky appear blue. But here's a good question. If violet light scatters even more than blue, why doesn't the sky look violet? There are three main reasons. First, the sun emits less violet light than blue light to begin with. Second, violet light is scattered so strongly that much of it gets absorbed by the upper atmosphere. And third, and most important, human vision. Our eyes are far more sensitive to blue light than violet. The cone cells in our retina respond weakly to violet, so even when violet light is present, our brain mostly ignores it. The result? Blue dominates our perception of the sky. Now, let's talk about sunsets. When the sun is overhead, its light travels a relatively short path through the atmosphere. But near the horizon, sunlight has to pass through much more air, sometimes 10 times as much. Along this longer path, almost all the blue and violet light gets scattered away, and what reaches our eyes are the longer wavelengths: yellow, orange, and red. That's why the sky glows with warm red and orange colors in the evening. Dust, pollution, and smoke can enhance this effect by scattering even more blue light, leading to especially dramatic sunsets. The sky's changing colors are a daily reminder that even ordinary sunlight can become extraordinary, simply by the path it takes through our atmosphere.